Hi, in this section we're going to cover node analysis with voltage sources. First we will show you the steps to write the node voltages. Then we're going to apply this one some examples. Here are the steps to find the node voltages. We're going to have two different cases. Case 1, if the voltage source is connected between reference node and non-reference node, that is easy because we can set the voltage non-reference node voltage as that voltage source easily. As an example in showing the right here, so V1 is given as 10 volts right away. Okay. Case 2 is different. In this case, voltage source is connected between non-reference nodes. So in this case we need to have super node. As you see here, green circle, this is our super node. We cover the voltage source right there. So we're gonna write the KCL for this circle here. Anything enter this circle will be positive. Anything exit from the circle will be negative. Why we need this one? We need this one because it's very difficult to find out the current over the voltage source at the beginning. So let's give example. In this example again, node 1 value is given because only voltage source is connected directly right there. That's number 1. So we know V1. So we need to find V2 and V3 node voltages. So first we're gonna have super node. We're gonna write the equation for this one. Any current goes through to circle. I1 is going in, I4 is going in. Those are positive. I2 and I3 is going out. Those are negative. So we can write the KCL for the super node like this here. So this is giving you equation number 1. Since we have two unknowns, V2 and V3, we need to write one more equation. The second equation we can write KVL from here. I go this direction here. So if you go to this direction from here to here, we're gonna have V2 because V2 right there. From here to here, we're gonna have 5 volts, capital V2. From here to here, going down here, that will be V3 will be equal 0. So our second equation is negative V2 plus 5, or like this here, plus 5 plus V3 will be equal 0. This is our second equation. Here the current, we're going to represent those current as function of node voltages. So how are we going to represent those currents, element current as node voltages? I look at the first I1. I1 is right there. I1 will be equal V1 minus V2 divided by 2 ohms. V1 minus V2 divided by 2 ohms, which is 10 minus V2 divided by 2 ohms. I2, it's more simple because V2 divided by 8 ohms. I3 is the one on the right side, so V3 divided by 6 ohms. I4 is top resistor, that will be V1 minus V3 divided by 4 ohms. So our KCL was I1 plus I4 minus I2 minus I3 was equal 0. So I1, take the I1 from here, that's what we have here. I4 is I4 here, then negative I2, negative I3 will be equal 0. We just put them under V2 and V3 parentheses. Okay, and we can simplify this one, eliminate even the denominator. Our equation comes like this: 15V2 plus 10V3 will equal 180. This is equation 1. Equation 2, we write that one from the KVL, if you remember, was minus V2 plus 5 plus V3 equals 0 put the 5 the other side. So this is our second equation. So T equation, two unknowns. I put them in the matrix form. I use the MATLAB to solve it. Then V2 comes 9.2 volts, V3 comes 4.2 volts. When I look at the circuit back again, so V2 right there and V3 right there. So after that point, I can find each current, element currents, or anything else you want to look for, you can find from there easily. Okay, next question is here. Similar question. In this case, we have only one voltage source between non-reference. That's why we need to have a supernode. We're going to cover that voltage source using the supernodes. So that's why we have dash green line here to cover that one here. So if you're going to write KCL for this one here, anything enter that circle is positive, anything exit negative. So 2 ampere entering positive, I1 exiting negative, I3 exiting negative, next I3 we have right there entering again back, that's why it's positive. Then I2 exits, that's why we have negative. And also here 7 ampere exit, that's why you have 7 right, equals 0. This I3, this cancel this one here. So if you simplify, you're gonna have I1 plus I2 is equal -5. So this is equation 1. Let's represent those element current I1, I2 in as a function of node voltages. So I1 is right there, will be V1 divided by 2. I2 is V2 divided by 4, is given here. I3 top 1 will be V1 minus V2 divided by 10. Okay, so we need to apply the I1 and I2. So our equation comes as more simple. Even we can eliminate the denominator here using common denominator. So 2V1 plus V2 equal minus 20. Second, if I look at the second equation here, we need to have another equation. We can't use any KCL anymore. We're gonna know the equation anymore. We need to apply KVL this case. The basic KVL we can apply from right here. So let me change the color here. I'm gonna change the color here. The voltage between right there, if you go this direction, will be minus V1. Voltage from here to here will be minus 2 volts. Voltage from here to here will be V2. That is equal 0. So minus V1 minus 2 plus V2 will be equal 0. So you can simplify that one here. You have equation number 2. Two equation, two unknowns. That rest is easy, but you're gonna put a matrix form, or you can take out the V2 from here, apply right there. You can find out V1 first, then find the V2, or apply a matrix form. I think in my notes I take out the one of them, I apply the other one, I found the values. So it's coming to V1 and V2 here. We have another example. In this example, we have 2 voltage sources. One of them is independent, as we seen before. The other one is dependent, but still voltage source. That's why those 2 voltage source between the non-reference nodes, we need to apply their supernodes. So we see green circle here, one of the supernode. Another green circle here, another supernode right there. Let's write those KCL for those 2 supernodes. Then we can write the other equation because we need more equations. Okay. First supernode, I1 is going out negative I1, I2 going out negative I2, I3 going in plus I3, and 10 ampere going in, that's why plus 10 here. So if you make some rearrangement, I1 plus I2 negative I3 will be equal to 10. That's equation number 1. Second equation from second supernodes on the right side. Let's start from I3. I3 exits right there, negative I3. I5 exits, negative I5 here, plus I1 entering from here. That's why I1 we have it, and negative I4 because that one is exit from the circle too also. So we can rearrange them as like this. This is our second equation. So next step, I think, is before going to write KVL equation, let's write those currents function of not voltages. See what's gonna happen. So when I look at this circuit here, I want to see I1. I1 bit the resistor between V1 and V4. That's why when you write V1 minus V4 divided by 3 ohms. I2 is the resistor on the left side, so V1 divided by 2 ohms is right there. We can write it. I3 between the V2 and V3, actually V3 and V2 because of direction. So I3 will be equal V3 minus V2 divided by 6 ohms in the middle right there. I4 is on the right side, 1 ohm resistor. That one's easy, V4 over 1 ohms. I5 in the middle here, that will be V3 divided by 4 ohms. We can apply them to our 2 KCL equation. So first KCL equation we apply, we simplify that one as function of not voltages. So we have V1, V2, V3 and V4 here. You can see here. And next slide we apply second KCL equation here. You'll see right second KCL equation. And we simplify this one. So we have here again V1, V4, V3 and V1, V2, V3 and V4 basically here. We have 2 equations so far and we have 4 unknowns. What is next step? We need to write some KVL equations. We can define a couple of loops right there. One of the loop is going, you can see on the left side, loop 1. Another one here, loop 2. Another one here, loop 3. We don't need 3 more equations. We just need 2 more equations. But we just define 3 of them. We're gonna write 3 of them, but we will not gonna use 3 of them again. I look at the first loop here. The direction I selected, so it's gonna be here from here to here, here to here as negative V1, positive 20, then positive V2. That is the first equation here. You can simplify that one here. I look at the second loop. Negative V3, positive 3Vx, and positive V4 will be equal 0. That's the second equation right there. You can simplify this one here. Again, this is enough, but let's write one more loop here. If I select again this direction here, first one is Vx, coming back from here, negative 3Vx because of negative entering right here. Then this will be here, actually, you can say 6I3, or you can say here V3 minus V2. Then minus 20 will be equal 0 here. That's another equation here. Again, we can define the I3. I3 is already defined. We can put it there too also. Okay, so this is our next equation. Next slide, we put those equation 1, 2, 3, 4, and 5 equations. So, but again, we have 4 unknowns. We just need to use 4 of them. So we are using this one, this one, this one, here, this one in matrix form to find out. It's easy to find with the MATLAB, put in the matrix form, then find those V1, V2, and V3. I want you to prepare some question and bring it to class so we can go over those questions.